So see here, relative velocity in two dimension. Suppose you have taken your velocity here, suppose Vb, and Va is here. There are two velocities. These two velocities are acting at an angle theta. Previously we have done relative velocity in a straight line, that is a straight line motion. Now here these two velocities are acting at an angle theta. Now suppose you want to get relative velocity of A with respect to B. So we will apply the same concept. First we have to superimpose a negative vector here, that is minus Vb. So that body Vb comes to rest. Now get the resultant of these two. This angle will be here 180 minus theta. The resultant of these Va and minus Vb is acting somewhere here. And this is called relative velocity of A with respect to B. Like this. Now you can calculate the magnitude of this is here. You can simply write here VAB is equal to VA plus minus VB. That can be written VA minus VB. But this is the vector addition. Now you can get magnitude of also this VAB. So the magnitude of VAB will be here under root of VA square plus VB square plus twice of VA VB cos 180 degree minus theta. Now we can take this is the magnitude, we can simplify it also here, and we can write VAB is equal to, that's magnitude is equal to under root of VA square plus VB square plus minus 2VA VB cos theta. So this is the resultant of these two, that is relative velocity of A with respect to B. Similarly, we can get this angle beta also. Suppose this is beta, we can calculate it. Here we can write tan beta is equal to VA sin 180 degree minus theta divided by VB plus VA cos 180 degree minus theta, and we can write VA sin theta divided by VB minus VA cos theta. So you can calculate here angle of relative velocity also with VAB. Now similarly you can calculate relative velocity of B with respect to A. So now we will see applications of relative velocity in two dimensions.